Hi, in this video we are going to look at the answers to the derivative practice that I sent out and look at strategies that we use for finding derivatives. On the first exam where we will be using our shortcut rules for derivatives, you'll have two parts to the exam. One part will not have notes and you'll have to find the derivatives straight. And then the second half will have notes. So we do need to be proficient at finding derivatives. As we look at problem number one, I know it's hard to read, but what we have is find the derivative of 3x squared over 2 minus 3 over 5x cubed. Now, it's easier if we first convert this to something that we can use the power rule with. So this 3 over 2 becomes the 3 halves, and the x squared stays x squared. Here we change the 2 over 5 to 2/5, and this x to the third that's in the denominator, we kind of bring it up to the numerator and make it x to the negative third. Now we can use the power rule, which says you take the exponent times the coefficient, and that becomes your new coefficient, and then you subtract 1 from the exponent. So when we take 2 times 3 halves, we just get 3. And 2, the previous exponent, minus 1, gives us a x to the first. For our second term, when we take a negative 3 times a negative 2/5, a negative times a negative makes a positive 6/5. And then x becomes to the negative fourth because we take negative 3 minus 1, which gives us the negative 4. If we go on to problem number 2, we have to do the same thing. So first we convert it to 5/9 w to the fourth, or excuse me, w to the negative fourth, because it's in the denominator. And the way we write 5 times the cubed root of w is 5 times w to the 1/3, because the cubed root of anything equals, let's call it x, would be x to the 1/3. In this case, it's w. Then we do the same thing with the power rule. We're going to take a negative 4 times 5, which gives us the negative 20 over 9. W becomes to the negative fifth because we subtract 1. And here we're going to take 1/3 times 5 and get 5/3 W to the negative 2/3, because when you subtract 1 from 1/3, you get a common denominator, and 1/3 minus 3/3 gives you the negative 2/3. 3 is very similar. We need to first convert, probably. Let's see. The 2.8x to the negative 3 can stay 2.8x to the negative 3. But this 0.6 over the cubed root of w squared, we should rewrite as 0.6 times x to the negative 2/3. Now, the reason it's x to the negative 2/3 is because it's being elevated to the second power, so that number goes in our numerator. The index on the root is 3, so that goes in our denominator, just like it did here. And it's negative, of course, because it was in the denominator. So for eliminating the fraction and kind of bringing it to the numerator, it becomes negative. So taking the derivative of this, of course, we multiply a negative 3 times 2.8, which gives us a negative 8.4. Then we subtract 1 from the negative 3, giving us a negative 4. Here, we're going to take a negative 2/3 times a negative 0.6, and that's going to give us a positive 0.4. When we subtract 1 from 2/3, again, we write 1 as a fraction, and that gives us the negative 5/3. Moving on. Here, when we take the derivative of e to the x is simply e to the x. And here, when we take the derivative of x, so let's say we had, if it was x squared, the derivative would become 2x to the first, because this gets multiplied and becomes the coefficient. The 2 becomes the 2 here. And then we would subtract 1 from the exponent. So x squared became x to the first. So as we do that with e is just a number. So this becomes, the e comes down in front, and we get e times x, and then we subtract 1 from e, giving us e minus 1 as our exponent. In number 5, the best way to do this is probably to convert it first to 9 times the natural log of x. That's the power rule for logarithms, which states if you have the log base b of x to some exponent, that is equivalent to bringing the exponent out front, r, times the log base b of x. So this exponent just comes down in front. Then we can take the derivative. The derivative of 4, of course, is 0. The derivative of 9 times natural log of x. Well, the derivative of natural log of x is 1 over x. So if you multiply 9 times it, you simply get 9 over x. On number 6, we're taking the derivative of a log function again, and the derivative of a log to a base that is not e. The rule for the derivative of a log of any base is that it becomes 1 over the argument. So this still goes with a 1 on top of it, and it goes to the denominator. And then this base, you multiply it by the natural log of that base. So the derivative of log base 2 of x is going to be 1 over x times 1 over the natural log of 2, and it's negative because it was originally negative. And the derivative of 10 times the natural log of x is just 10 over x. On number 7, finding the derivative here, derivative of 10 is 0. The derivative of x is 1, we get here. And the derivative of 10 to the x, this is the derivative of a number to a power. So we know the derivative of e to the x is e to the x. The derivative of some different number, in this case it's 10, but it could be any number. I'm going to call that number b. If I take the derivative of this, it also is just b to the x, but times the natural log of b. So that's why this answer becomes 1 plus 10 to the x times the natural log of 10. Looking at number 8, we have 3 times the log base 5 of x. So this would become, I kind of left out a step here. 3 would be multiplied by the derivative of log base 5 of x would be 1 over x times 1 over the natural log of 5, and I just multiplied the 3 and put it on top of the x. Now, in this problem, we need to use the product rule because we have this x cubed times the natural log of x. So the product rule states that if you want to take the derivative of two functions, I'm going to call it f of x for the first function and times s of x for the second function. The derivative of that is the first function remaining the same times the derivative of the second function, then plus the second function remaining the same times the derivative of the first. Now we know that we need to do this because this has a variable in it and that has a variable in it. So that's why we'll proceed like this. So doing that formula, the way we take the derivative of this product is we write the first times the derivative of natural log, which is 1 over x, and then plus the second, which is the natural log of x, times the derivative of x cubed, which is 3x squared. Now this can simplify because if you have an x cubed and it's divided by an x, that makes x squared. I like to write the 3x squared first on this one. So if you write it first times the natural log of x, it looks like that. Then you might recognize both of these terms have an x squared in it, so you could factor the x out, leaving you this. However, if you don't have to solve, it's fine to leave it as its first step. I think we'll pause here and we'll do the second half of this worksheet in another video. Hope this is helpful.